and few things beyond observability as well, right? Because the eventual goal is to reduce the mean time to detect and mean time to resolve. So how do we do that? Just having observability will not help us do that. So I'm just going to talk about observability by and large, especially focusing on the service that we have on AWS, but few topics beyond that as well. So before we discuss about what is observability, I would like to discuss about why do we need observability, right? Like we said, application or system that we have can fail for multiple reasons. And if we don't have a systems in place to understand what is happening inside these systems, we will never be able to understand when something goes wrong or when something is about to go wrong, right? So how do we get to know about these things? So that's where your traditional monitoring comes into place, where we have metrics and logs. So metrics is various parameters of the systems and applications that we record on a periodic basis, on a time series basis, right? So we record it in a time series database, we have time series data, and we record various parameters of the applications and the systems. And then we have logs. Logs is nothing but a record of each and every activity that a system or an application performs in a chronological order. Logs helps us understand when something goes wrong in a system, so that we can go backtrack, figure out what happened, what was happening before that, and what actually happened at that time, and why that specific error happened. Now this is all good until virtualization and cloud took over. With onset of virtualization in cloud, things drastically changed. The way we built applications drastically changed, right? Applications became highly distributed, highly multi-layered, right? With highly distributed and multi-layered applications, there's a challenge with monitoring, because with just metrics and logs that we collect with the regular traditional monitoring, it becomes very difficult to pinpoint where this issue came from, because there are so many moving parts into your application. It's just not one application. There are many moving parts into your application. There are so many components. One component is dependent upon. So that becomes, that adds a complexity into monitoring. It becomes very difficult for us to understand where exactly the problem is. So that's where observability comes into picture, right? So observability helps us get insights about the systems that we have and quickly identify where the problem happened, why it happened, and what we need to do to fix it. So there are three pillars of observability. We have metrics and logs, which we already discussed, and then we have traces. Traces is nothing but a sequence of events. So when a request is made, that entire workflow is recorded, and the sequence of events. So this right from when the request was made, throughout that life journey of that particular request, throughout the different components in that application, it goes through and tracks that and keeps a metadata of various parameters with respect to that application or the system, right? So that is what traces do. So trace has something called as trace ID, which is unique for a specific sequence of activity that is performed on an event. So that's about traces. So that's pillars of observability. Now, when we come to the observability, there are different components. So we know infrastructure monitoring, which we have traditionally been doing, which is cloud monitoring, container monitoring, network monitoring, server monitoring, right? And we have application monitoring. Application monitoring basically refers to application performance monitorings. You have logging and tracing and database monitoring. And then we have digital experience. Digital experience is basically we do synthetic monitoring, real user monitoring, and user behavior monitoring. So synthetic monitoring, if you are not familiar with synthetic monitoring, this is something that we should all have in our IT landscape. Synthetic monitor helps us simulate user interactions with our applications. So basically, let's say if you have an e-commerce application, right? How do you get to know that if a workflow within your e-commerce application is broken? Not that entire application is down, right? But just a workflow is broken. So we can simulate user interactions with your application using synthetic monitoring. So it could log into your systems, it could search through your catalogs, it could add your product into the wish list, or you could place an order on that. And if something breaks, you get to know that. Even so, before end user gets to know about the problem, you can quickly identify when something goes wrong with your application. So that's about synthetic monitoring. Real user monitoring, as the name says, it's about understanding, it's about monitoring the actual user's interaction with the application itself. So if something goes wrong, or if the specific interaction that the user has with the application has some latency or any other issues, we will be able to monitor the reasons, what was the kind of interaction that the user was making with the application, to make intelligent decisions on how do we improve the experience of the user, right? So that's about real user monitoring. Then we have user behavior monitoring. This is specifically from the security standpoint. So from the security standpoint, so when a user interacts with an application with a malicious intent to either hack the system or leak the data or with some other malicious intent, user behavior monitoring helps us understand the user, based on the user interaction patterns, tells us that the user is having a malicious intent and is trying to behaving in a way that is not intended. So we can quickly, proactively go ahead and deny access to the user, right? So that's about digital experience monitoring. So I just wanted to classify the systems here, and what we see here in the bottom is the services that AWS offers for each of these components. So we'll discuss that here. This is the entire stack of services offered by AWS. So the left, you see these are all the AWS native solutions that we have, and the right we have open source managed services from AWS. Before we talk about any of these stack, what is most important thing is instrumentation. So what is instrumentation? Instrumentation is all about collecting or having the mechanism within your applications and systems to generate the data that we need. The data that we need is metrics, logs, and traces. So instrumentation helps us generate those data that we need for observability, basically metrics, logs, and traces, right? But once we have those data ready, we need collectors, we need agents which could take that and send it to the observability platforms of our choice. So on the native side, we have AWS CloudWatch agents and X-ray agents. CloudWatch agents are helps us send metrics and logs into CloudWatch. AWS X-ray agent is as a name for the service used by AWS for tracing. So AWS X-ray agent does what we talked about earlier as tracing, and it helps us collect the traces from the applications built on the AWS services, and then it helps us send it to the AWS X-ray service, right? So once we have, so the data that these agents collect is sent into CloudWatch, and we have CloudWatch metrics, CloudWatch logs, and CloudWatch synthetics and X-ray to collect that. So CloudWatch synthetics does the synthetic monitoring that we discussed a couple of minutes back. The next stack on top of this is CloudWatch events. CloudWatch events helps us create conditions on the metrics and the logs that we collect and trigger events so that we can create additional workflows on top. So let's say there's a specific condition that got met and we want to create an automation around it. We could use CloudWatch events to do that. Dashboarding and visualization is a key part of observability because if we need insights, we collect data, that's good, but how do we understand what went wrong where, right? So dashboarding and visualization is a key part of observability, and CloudWatch dashboards help us do that. I'll come to alarms in the next slide because there's a detailed topic on that. CloudWatch RAM is real user monitoring that we discussed about. CloudWatch evidently is a service that helps us do A/B testing, or what we call as a dark launching, right? So feature flags. So we can, developers can actually release a new feature or a couple of new features to fuse a set of end users to consume it and see how the users are interacting with it, so that they can understand the user interaction feedback and then enhance the features that they are developing and then release it to the wider audience. So that's CloudWatch evidently. Then we have all the insight services, which actually makes use of some sort of additional logic to get some insights into the data from the data that we collected, right? So container insights collects data from the microservices and the containers we have and gives us an insights into what's happening. Lambda insights gives us more details about the metrics from the Lambda. So there's something called as Lambda extensions, and it's available as Lambda layer. So we could add that Lambda layer to the Lambdas that we have, and that will help us get more insights into the operations of the Lambda function that if you're not using it, that's really great for you to use. Then we have contributor insights. Contributor insights is basically the top contributors in a specific parameter. So let's say n number of top system that's consuming CPU, something of that sort. So you get a contributor insight for that. Application insight basically makes use of ML models to predict based on the application metrics that we collect and the logs we collect. Application insights helps us understand what's going to happen, what is currently happening with the application and what might happen. So it also has a predictive capability with application insights. Then we have metric insights. Metric insights will help us slice and dice the metrics that we collect in the CloudWatch and then make much better sense of metrics that we collect. On the top we have the service lens. This is a visualization solution. The service lens is basically built using the X-ray traces. So X-ray traces gives us the capability to connect all the services in a distributed system, right? So we have various, like in a highly distributed system, there are so many components that is dependent on one another. And as we do the tracing, we get the flow of requests from one system to the next, and that helps us create a map of all the services that is in our system. So AWS Service Lens helps us do that. AWS Service Lens also helps us to visualize. So let's say there is a trace which there is some error in one of the traces. So if you go into the trace, you can actually look at the logs, which is also part of that particular trace. So there is a way that we can inject trace IDs into the logs, and it can help us correlate between logs and traces so that we can quickly identify what went wrong where and what is the cause of the problem. Coming to the open source side of things, we have OpenSearch service which is managed instance from Amazon. We have Prometheus, which is managed instance service from Amazon. We have Hager and Zipkin. But the most important part is AWS distribution of OpenTelemetry. OpenTelemetry is a CNCF project. OpenTelemetry has APIs, libraries, and agents that helps us collect metrics and traces, right? So it helps us collect metrics and traces from applications, and we can send it to any tool of our choice. So the cool part of OpenTelemetry is, let's say if you are doing tracing, like we do with logging, we have to write the logs. We have to code the logging into our application. But with OpenTelemetry, there is something called as auto-instrumentation. If you enable auto-instrumentation, it's actually going to do you don't have to make any changes into your code, but it will automatically start creating traces in your application, right? So next thing is, so that's alerting. I'll get to the alerting later. Yeah, so here we have Amazon OpenSearch. OpenSearch actually helps us collect metrics and logs and helps us search through the services, right? Prometheus is basically the go-to solution for almost everybody who's on the Kubernetes or the container space. And we can have a centralized Prometheus instance managed by AWS for monitoring. So it comes up with all the Prometheus capabilities. Hager and Zipkin is used for tracing. So the traces that we collect using the OpenTelemetry agents, we can send it to Hager and Zipkin. And on the visualization side, on the open source side, we have Amazon managed Grafana. So Grafana, there is another session right before the lunch there, where we talked, they talked quite a lot in detail about Grafana and the various services that they offer. So Grafana is a very popular visualization tool. It does not keep any data on its own, but it has a lot of connectors to a plethora of data sources, right? So it can connect to CloudWatch, it can connect to InfluxDB, it can connect to other observability tools as well, and connect and give you the dashboard that you kind of want. But what is missing here is a kind of insight. So if you want more insights into the data that you connect on the open source side, you will have to build something on your own using the insights and the ML, right? So you have to create those instances. So having observability is one part, right? We have all this. Reaching this far in itself is a big challenge for most of the organizations today because of the legacy reasons. Migrating into something of this sort with all the tracing logs and metrics that we discussed, with the trace being injected into logs, it's all complicated. But once you reach there, what is the next part? Can we all keep looking at the monitoring systems often and see when something goes wrong? We cannot. So we need to build alerting solutions, right? We need to get notified. So there are two ways to create notifications. One is static. Static thresholds, I don't have that in the slide, but static is something that we all are aware of. So based on the understanding of the applications and the systems, we have a prediction on what would be the right value and beyond which it is abnormal. So we set thresholds. So whenever a threshold is breached, we get notified about the problem. So it just indicates that there might be something that's wrong. Kindly look at it. So that's about static method. But what I'm going to discuss in detail about is anomaly detections, right? So anomaly detection is basically a method by which you look at the standard band of parameters that you receive. So let's say it is CPU. So if you are monitoring the CPU usage, if you are automatically, if you don't know what is the, okay, let's say if you have an application, you have deployed the application, there's a new application, you don't know what is the acceptable level of CPU for that specific application. Is it CPU intensive application? Should I set the threshold at 95? Should I set it at 80, right? So you can use anomaly detection. What it will do is it will take historical data, it will run a machine learning models, and it will understand what is the band of CPU which is normal for that particular instance. And whenever there is an outlier to that value, it will notify us. So it will create alerts and it will notify us, right? So that's with respect to CloudWatch metrics. Similarly for CloudWatch logs, it looks at the past logs, recognize the patterns in the logs, and whenever there is a deviation from the patterns, it will notify us, right? So it has a capability to do that. So similarly, if there is a variation in the known pattern, so okay, if there is a value in the dynamic token, right? So if there is a dynamic token which usually comes with a defined set of values, and if there is a variation in that, if there is something that's changed in there, then we get notified about that. So this is about anomaly detection, right? If we can do alerting, static alerting for logging with respect to patterns, we can say that if you find this particular string or this particular pattern, you notify us, you send an alert to us. But if you go with anomaly detection, it can automatically do that for us. We don't have to bother too much about understanding or finding what are the patterns that is an outlier. Similarly for OpenSearch, it uses random cut forest algorithm. So it actually does look at the outliers of the metrics that it collects and helps us do the alerting. We can also create custom solutions based on using QuickSight and SageMaker. So we have to build our own solutions on this, but QuickSight also gives us the capability to do the forecasting. So outliers is basically what is out of the band, what is not normal. Forecasting about what is expected and what is normal, and if something goes outside the normal, then it gets notified. So we can create solutions using QuickSight and SageMaker if you want to. So I'll quickly run through the rest of the slides. So these are the capabilities. So we have CloudWatch, we have OpenSearch, we have Prometheus, and we have Managed Grafana. And these are the ways in which we can notify, right? So notification is basically, it could be a Slack notification, it could be a PagerDuty, paging, it could be a ServiceNow ticket or a Jira ticket, it could be anything of that sort, right? But how do we integrate that from the observability platforms? So that's where these kind of systems comes into place. So we have for CloudWatch, so the one thing that which is common in all this is Amazon SNS topics, because it's all managed by AWS, but we have other integrations as well possible, right? With CloudWatch, we also have ops items in ops manager, ops center, and we also can create incident in the incident manager, right? So both of the ops items and the incident manager is an AWS service, which we can use for integrating with ServiceNow if you want to do that. Now, alerting is one part, but we have so many components, moving parts, and there are n number of applications in your environment. You will be bombarded with alerts if you just don't do anything. If you just create those alerts, you will be bombarded with so many alerts that you will not get to know which one to act upon. What is an actionable incident that you want to act upon, right? So how do you do it? How do you get to know which one to act upon? For that, we need to reduce the noise in the system, right? We need to have mechanisms in the system, in the alerting system, so that we can reduce the noise. We need to reduce the number of incidents that we get. We need to get incidents that is actionable, which makes sense to us. So these are the different methods in which we can correlate alerts or incidents for that matter. Before I get to that, there is one thing that is pretty basic, which is a specific alert configuration should only create one ticket, right? So let's say the threshold is breached, you get a ticket, it goes down, then again if it triggers, goes up, it should not create a new ticket. If the ticket is already open, it should actually update the ticket, it should not open the ticket, right? So that capability comes from the ops item, from the ops center and from the incident manager and the AWS. But beyond that, we have common cause identification, which is that if the root cause of an alert is common, we should correlate all that into one incident, because it does not make any sense to create multiple tickets when the root cause is same. The second item is dependency mapping. Dependency mapping, we get the dependency mapping using tracing. So in the distributed system, we have the service lens, which we talked about. But with tracing, we get the complete map of all the systems that it is dependent upon. So based on that dependency mapping, we can look at the alerts that is getting generated. So let's say service B is dependent on service A, and if service A fails, we can also say that if an alert comes from service B, it might be because service A failed, so we can correlate that. So that is dependency mapping. Then we have threshold aggregation, which is to say that CPU is 30%, memory is 70%. It's not breaching, individually it's not breaching, but we can set conditions saying that, okay, if these and these conditions match, so threshold aggregate, then you send an alert, because that can cause a problem. So these two together can be an indication of a problem. It alone in itself cannot be a problem, but when it happens together, there can be a problem with that. Then we have temporal correlation, which is timing and sequence. So let's say this event happened and this event happened and this event happened. So okay, maybe this, and there's a timing gap, which is okay. So we understand that there is some sort of a possibility that these events might be correlated, right? So that is temporal correlation. If alerts come from a specific geography, especially from the data center perspective, if an entire data center or an office is down, that might be because of power outage or something of that sort. That's geographical correlation, because we don't need 200 or 500 systems in that data center or the office to give us tickets, right? We need to correlate that automatically. So that's how we reduce the noise in the system. Next is pattern recognition, to use ML to create pattern recognition models and then automatically do that correlation. So this is a few things that AWS provides where we can do some sort of correlation. So the op center that I said that it will suppress if the incident is triggered again from the same alert configuration. System manager, incident manager also does the same thing. We have something called as composite alarms in CloudWatch. Composite alarms is, we can give math expressions to combine multiple metrics and then create an alarm out of it, right? So if multiple conditions meet, and if a math operation operation exceeds a specific value or any stated condition, it can send us composite alarms. And the last thing is what we discussed, a DIY solution that we built. So we have correlated the alarms now, right? We have reduced the noise in the system. What next? We need to have systems in place which can automatically remediate the issues. Looking at the data that we had in our organization, it's not easy to remediate all the issues, but all the tickets that we have are recurring issues. The ticket that we have the most are recurring issues and which can be fixed, and there is a very clear runbook for fixing those issues. So we can fix those issues quickly, right? We don't need a human intervention to fix those issues, right? So we can have custom solutions built to do that, but AWS provides few solutions. So we can use auto-scaling, AWS auto-scaling to do that. We can use EC2 auto-recovery to do some sort of self-healing. We can use AWS System Manager integrations, automations and documents to run commands to automate many of the actions based on CloudWatch events, right? So we can build solutions in AWS to automatically remediate issues. Or we can create custom solutions using Event Bridge, API gateways, Lambdas. We can create custom solutions to go fix the problems, right? So as long as the solution is straightforward, we can use these systems, right? So this is the entire stream of events that we discussed today. Instrumentation, observability platform, alerting, alert correlation, ITSM, incident response management solutions, collaborations, and then auto-remediation and auto-diagnosis, right? I hope this session makes sense to you and you can use it in your IT landscape. This helps you make the operations team's life easier, right? That's it. Thank you. Thanks a lot for the organizers to giving me the opportunity. Thank you. Bye.
Thank you, Ahamed. Sure. Thank you for such an enlightening session. Let me invite Neha to hand over the talk now to Ahamed. Can we have a big round of applause?
Thank you.